Hello everyone, I welcome you all to this class. This is mathematics class and we are here again to consider another important topic. Today we want to consider Bernoulli equations. Actually, a Bernoulli equation is a first order ordinary differential equation because you have the first derivative in that equation. And in this class, I will show you how Bernoulli equations are and how to solve Bernoulli equations. Now, a Bernoulli equation is an equation of the form y prime plus p of xy equals q of x y raised to power alpha. Now, in a Bernoulli equation, you are going to have what? Three terms. The first term is a term with what? The first derivative of the dependent variable. The dependent variable is always the one having derivative sign. That's this y prime. Then the other two terms contains the dependent variable y. Then one of it, the power of the dependent variable in one of the other two terms is 1. What is the power of y here? 1. But the power of the dependent variable in the other term should not be 1 or 0. What is the power of y here? Alpha. But alpha should not be 1 or 0. It can be any other index. Alpha can be any other index, but it shouldn't be 1 or 0. So this is how Bernoulli equations look like. The question now is how do I solve Bernoulli equation? A Bernoulli equation is given to me, I want to solve it. How do I solve it? We use appropriate substitution. Now, we can use the substitution w equals y raised to power 1 minus alpha. Now, this is just change of variable. We are changing the variable, we are changing the from the y to w. So, we are changing the dependent variable from y to what? W, so that we can solve the problem, right? So this is the appropriate substitution, and with example you are going to see how we are going to use this substitution to solve problems, right? So let's look at this question. Solve the equation y prime plus y equals x y raised to power 2 over 3. That's an equation given to us. Is this equation a Bernoulli equation? Clearly you have what? 3 terms, right? Just as we have in this equation, we have 3 terms. The first term has the first derivative of the dependent variable. In this case, y is the dependent variable because y is the one that has derivative sign. So you have the first derivative, which is in line with this, the first term here. You have first derivative. Then for the second, you have the other two terms contains the dependent variable y. Both of them contains the dependent variable, just as in this one, both of them contains the dependent variable, right? Then the power of one of the dependent variable is 1. What is the power of y here? 1. Just in line with this. And the power of the other dependent variable is not 1 or 0. The power of y here is 3 over 2, which is not 1 and is not 0. So it is in line with this Bernoulli equation. So we can solve it. Let's look at solution to this problem. Solution. So we have the equation given to us, right? This is what is given to us. So we use the substitution. What is the substitution? We are going to say let w be equal to y raised to power 1 minus alpha. This is our alpha. For alpha is what? The index of y here. Where alpha is equals to, what is alpha here? 2 over 3. 2 over 3. So this implies what? This implies that w is equal to what? Y raised to power 1 minus, our alpha is 2 over 3. So this simply implies that w is equal to what? Y raised to power 1 over 3. What we are going to do is to make y the solution to the formula, because we want to substitute y, right? So we want to write y in terms of what? W. So that after that we can substitute y for w here. So I will make y the subject of the formula because I want to write in terms of w. Now, clearly here we can make y the subject of the formula by using the knowledge of what? Law of what? Indices, right? Now I want the power, for me to make y the subject of the formula, the power of y here should be what? 1. So this implies, well, let's just write it. Take the cube of both sides. So this implies w raised to power 3. I'm taking the cube of both sides is equals to y. So I've made y the subject of the formula, right? Now let me call this one equation 1, right? We are going to differentiate. Now if you look at this equation, y is the one having prime, which is the dependent variable, and x will be independent. So y depends on what? X, because x is the independent variable, right? So if you are substituting y for w, w also should depend on what? X. So w is now a function of what? X. This w is a function of x because it depends on x. This thing is the same as that y is equal to, what is w is, I can write w as w of x. I'm showing it clearly because w depends on x. Since y depends on x and you are substituting w for y, but we are having w raised to power what? 3, right? So what is the derivative? What is y prime? If you differentiate this, how do you differentiate? You use your what? Chain rule formula. You differentiate the inside. If you differentiate the inside, what will you get? You get w prime. Multiply by, you differentiate the whole of the bracket, right? So what is the index of the bracket? 3. You bring it down 3 times. You remove 1 from 3. If you remove 1 from 3, what will you have? 2. So you'll be having w raised to power what? 2. That's it. So this implies that y prime is equal to, what do we get there? I can write it as 3 w raised to power 2 w prime. So let me write it as 3w raised to power 2 w prime. So this is the derivative, right? So I will now go to my equation and substitute. So let's rename some things, right? I use equation 1 here, then use equation 2 here, then this last one I'll use equation 3, right? Then I've gotten the respective things I needed, because I've gotten y prime in terms of what? W, so that I can remove one y prime and replace it with this. Of course, I've gotten y in terms of w. This place I made the y the solution of the formula, so that I can replace it, right? So I've gotten the things to replace. So I can now say substitute equation 3, 2 in 1. We get, so the next step now is to substitute equation 3, equation 2 in equation 1. Let's substitute. This implies what? We are going to remove y prime and replace it with this, because I've gotten it in terms of w. So y prime is now 3w raised to power 2 w prime, right? Plus, what is y? Y is what? Y is w raised to power 3 from equation 2. W raised to power 3. Then equal to, what do we have here? We have x, y raised to power 2 over 3. What is y? From equation 2, y is w raised to power 3. So you have w raised to power 3, that is my y. But y is raised to power 2 over 3, that's all raised to power 2 over 3. Now if you can simplify this one further, right? Because w raised to power 3 or raised to power 2 over 3, by the law of indices you multiply the index. That's 3 times 2 over 3. What will happen? 3 cancel 3, remaining index 2. So this simply implies 3w raised to power 2 w prime plus w raised to power 3 is equal to x w raised to power what? 2. That's what we now have. Now what do? You are going to make this one having the first derivative sign. You are going to make the coefficient to be 1 before you solve it. So what do? Divide everything by that coefficient. So I have written it down. Divide both sides by what? 3w squared, because 3w squared is the coefficient of w prime. So this implies if I divide this by 3w squared, I have w prime plus divide w cubed by, so I want to do w cubed divide by 3w squared, because I'm dividing everything by this. So if I do that, w squared divide w cubed, I have w at the numerator. Then so I'll be having w divided by 3, right? Then equal to, what do we have here? X w squared divided by 3w squared, right? Because I'm dividing everything by 3w squared. What will happen? W squared cancel w squared, we'll have what? X over what? 3. So that's what we'll have, x over 3. Now whenever you solve a Bernoulli equation, it will lead you to first order linear ODE. It will lead you to what? First order linear ODE, the one we have solved in our previous class. How does first order linear ODE look like? They look like this: y prime plus p of x y equals q of x. That's how they look like. So this is the format for first order linear ODE. So you can see it's looking like that. This q of x is the function of the independent alone. So you can see this is the function of x alone, right? Then p of x is the coefficient of the dependent variable. Our dependent variable is w because w has prime. So what's the coefficient? The coefficient is 1 over 3, because I can write this as, because this implies w prime plus 1 over 3 w equals x over 3. So the coefficient is this p of x. So we got a first order ODE. Now if you have a first order ODE, the integrating factor is given by exponential integral of p of x dx. P of x is the coefficient of the dependent variable. The dependent variable in this case is now our w. What's the coefficient? 1 over 3. So our integrating factor I dot f, this implies that our integrating factor I dot f is equal to exponential integral of 1 over 3 dx. So that will be the integrating factor as exponential. What? Because our p of s is 1 over 3, the coefficient of the dependent. So if you want to integrate a constant, what's the result? The integral of a constant is that constant multiplied the variable we are integrating with respect to. We are integrating with respect to x, and our constant is 1 over 3. So the result will be that constant 1 over 3 multiplied by that variable x. So this is our integrating factor. So what do? Multiply the ODE by the integrating factor. That's the next step. When you are solving a first order linear ODE, when you have got your integrating factor, you use the integrating factor to multiply the ODE. That's the reason of getting the integrating factor. Use to multiply. So we multiply this by the integrating factor. So multiply w prime by the integrating factor. We have, so we are going to have exponential 1 over 3 x w prime plus Multiply this by the integrating factor. You have 1 over 3 exponential 1 over 3x w equal to, multiply this by the integrating factor. You have x over 3 exponential 1 over 3x. So the next thing is to write this in derivative form. Now this left hand side, the left hand side is the same thing as the derivative of the product of the dependent variable and the integrating factor. I told you this in our previous video when we were solving first order linear ODEs. So when you have multiplied the two sides of the equation by the integrating factor, then the left hand side of the equation is the same thing as the derivative of the product of the dependent variable. The dependent variable in this case is w. W is the one that has prime in this equation, right? W. So that's the product of w and the integrating factor. What's the integrating factor of this? So that's product of the integrating factor and our dependent variable w with respect to what? X. The derivative of this will give you the total of the left hand side of this equation we have here. So this will be equal to the right hand side, x over 3 exponential 1 over 3x. Right. So what do? You put integral. Integrate both sides. The purpose of writing the left hand side like this is that we can put integral here so that integral can cancel the derivative sign, right? So we'll now put integral. So that's integral of d dx of exponential 1 over 3x w dx equals integral of x over 3 exponential 1 over 3x. So I have put integral at the both sides, then I'll evaluate the integral. So integral will cancel the derivative sign. So we'll have this quantity inside. So this implies exponential 1 over 3x w is equal to integral of this. Now this x over 3, I can factor this 3 at the denominator. So I'll have 1 over 3 integral of x exponential 1 over 3x dx. So I have to put dx here, right? Dx. So this is what I have. The next thing is to evaluate this integral. What this integral will be. That's the next thing we have to do. Now what will be this integral? But this is a product of what? Two functions. X is a polynomial and exponent will have this is exponential function of x and this is a polynomial function of x. So if you are integrating product of two functions, what do? You use product rule of what? Integration. So we have the formula is integral of u dv is equals to uv minus integral of v du. Right, that's the formula. So u is one of this function and the v is one of this function. The one you are going to call u is the one that can vanish if you differentiate. If you differentiate exponential, can exponential vanish? Even if you differentiate it 100 times, it cannot vanish. You'll still be having the exponential left there. But if you differentiate x can vanish. So this one the one that will vanish is the one you call u, and the one that will not vanish is the one you call what? Dv, right? So we are going to do the integration. After that, we are going to carry the we put the answer in our next line. So let's do the integration somewhere. Let u be equal to x, right? So u is I've called u the first function x because I know that x can vanish if you differentiate. So I'm going to differentiate it because in my formula I need my what? Du, right? I need du. So this implies if I differentiate this, I'll have du dx. So I will differentiate du with respect to x. If you differentiate x, what will you get? You get 1. So make du the solid of the formula. So you now get something to substitute for du here. So this implies that my du is equals to dx multiplied by 1, which is what? Dx. Right? So the next thing to get is what? You need your v. But since I've called u the first one, my dv is the second one. So I'm going to say let dv be equals to exponential 1 over 3x. So this one, the what you got the v, you are going to integrate it, because to get v now you put integral here. If you put integral here, integral will cancel the derivative sign. You have v equals integral of this, of exponential 1 over 3x. And this is equal to what? How do you integrate exponential function? If you want to integrate exponential function faster, that's you want to use shortcut, just differentiate the exponent. The exponent is 1 over 3x. If you differentiate this, you get 1 over 3. If the derivative is a constant, then you can use the shortcut and get the answer faster. But if the derivative of the exponent is having a variable, for instance, if the index is x squared, if you differentiate x squared, you get what? 2x. Has your x vanished? No, x is still there, so you can't use that. But if the derivative of the exponent, is a constant, then you can use this. So the result, it will be just this, the exponential function, which is exponential 1 over 3x divided by the result of the derivative of the index. When we differentiated the index, we got 1 over what? 3, right? So we are using this because so if the derivative of the index is a constant, use the constant to divide the what? The exponential function. That will give it the integral of the exponential. So this is same thing as what? 3 exponential 1 over 3x. So that's the result. So this will be equals to 3 exponential 1 over 3x. That's my v. So I will quickly use this formula. This implies that integral of u dv will be equals to, we have uv, that's product of u and v. U is x and v is 3 exponential 1 over 3x. So if I multiply this and this, I'll have 3x exponential 1 over 3x minus integral of what? In the formula, minus integral of v du. What is my v? My v is this, is 3 exponential 1 over 3x. That's what we got for our v, right? Du. What is du? We solved, we got du to be what? Dx. So our integration has not finished. So we need to integrate this last one. But what we have is just 3 exponential 1 over 3x. Using my previous explanation, you differentiate the index. What's the index? 1 over 3x. So if you differentiate this index, what will you have? 1 over 3, just as we did it earlier, which is a constant. So the result of this integration is the exponential function divided by the derivative of the index. Derivative of the index of the exponential gave us 1 over 3. So my result of the integral is this exponential function divided by that result of the derivative of the index by 1 over 3. And this is same thing as 3. This if you solve this, you have 3 times the 3 exponential 1 over 3x, which will give you what? Which will give you 9 exponential 1 over 3x. Then, so what we have is 3. So what we have is 3x exponential 1 over 3x. Then this gave us what? It gave us 9 exponential 1 over 3x. That's what this one gave us. Then, so we're going to go back to this and substitute it. This implies that my exponential 1 over 3x w will be equal to what? We'll substitute it here. We have 1 over 3 into, we have 1 over 3 here, right? Then the integral of this is this thing we got here. 3x exponential 1 over 3x minus 9 exponential 1 over 3x. That's the result. Then you are going to put plus c. C is the constant of integration, right? After the integration, you normally put plus c. So this implies exponential 1 over 3x w is equal to, multiply this bracket by this 1 over 3 outside. If you multiply the first term by 1 over 3, what will you get? You have x exponential 1 over 3x, because 1 over 3 will cancel 3 and 3 will get cancelled, right? Then if you use this to multiply here, 3 will divide 9, leaving 3 here. So you have negative 3 exponential 1 over 3x. So that's the result we got. Plus the constant of integration, what? C, the last one we have here. So what do you do now? You make your W the solution of the formula, right? You make W the solution of the formula. So how do you make W the solution of the formula? You divide both sides by the coefficient of W. The coefficient of W is exponential 1 over 3x. So divide both sides by exponential 1 over 3x. So if you divide both sides by exponential 1 over 3x, so what do you divide here by exponential 1 over 3x? This implies that W will be equal to, because if you divide this by exponential 1 over 3x, you get W. Divide this by exponential 1 over 3x, you have x. Divide this by exponential 1 over 3x, you have negative 3, plus the last one, you divide c by exponential 1 over 3x, because we are dividing everything by what? Exponential 1 over 3x. So you'll be having c divided by exponential 1 over 3x. But this thing, you can write this as what? You can write this as c times 1 over exponential 1 over 3x. Are they the same? Of course, they are the same, because c divided by exponential 1 over 3x is the same as c times 1 over exponential 1 over 3x. Why I'm writing this is because I want to use the law of what? Indices. Because I want to remove this fraction. I want to remove this 1 over. So how do I remove this fraction? I will introduce a negative sign on the index of the exponential. So if I introduce negative sign here, so I'll have c exponential negative 1 over 3x. That will be the result. So we are going to return our y, because our dependent variable is not w. W just helped us to solve the problem. The main dependent variable is y in the original equation, right? Remember, right? So we are going to return that. But from 2, we have that w raised to power 3 equals y. So, but from equation 2, we solved that's the first step in our solving. We made that place, we made y the solution formula after using our change of variable formula. That's after using our substitution formula. We solved and we made y the solution formula and got y in terms of what? W. And this was our equation 2. You can go back and check it. This implies that y will be equal to, but w is this expression, right? So y will be this expression raised to power 3. So my y will be equal to x minus 3 plus c exponential negative 1 over 3x all raised to power 3. So this will be the result of this. This will be the solution of this very Bernoulli ODE. I hope the class is interesting. I'm expecting you in our upcoming class.